Hello, fellow 7th grade science teachers, and welcome to the Geology on Mars unit launch video. My name is Zakia. I teach 7th grade science in Chicago, Illinois. To the right, you see a picture of me in Thailand with a baby tiger. I went a few weeks ago. I had the pleasure of feeding the baby tiger. It was really scary, as I'm sure you can see in the picture. Let's go ahead and dive in. So the Geology on Mars unit has 11 lessons, and throughout these 11 lessons, we'll be focusing on answering the big unit question of how can we search for evidence that other planets were once habitable? Before we begin, 1. Read and annotate the unit overview, unit at a glance, and standards. 2. Read and annotate the science background knowledge. And 3. Print out the unit internalization guide and get a pencil ready. Why does this unit matter? Geology is the study of Earth, its history, and how it works. This helps us understand issues with energy, water, resources, climate change, and natural disasters. Let's now dive into the chapter overviews. Chapter 1, Comparing Earth and Rocky Planets. The Chapter 1 question states, what geologic process could have formed the channel on Mars? In the first lesson for Chapter 1, students consider the unit question, how can we search for evidence that other planets were once habitable? To begin to answer this question, students learn that Earth is one of 4 rocky planets on our solar system. Students compare Earth's hydrosphere, atmosphere, biosphere, and geosphere to the others of rocky planets. Through this activity, students identify Mars as a compelling place to search for evidence of habitability. After this focus on Mars is established, students watch a short video interview of a real geologist. This geologist describes how she uses understanding of Earth to inform the research for signs of past habitability on Mars. In Lesson 1.2, Observing the Surfaces of Mars and Earth, students review the parts of the Earth system by watching a short video. Then students use an interactive digital tool, the GeoMars Sim, to explore the surface of Mars and look for landforms that could be evidence that water was once flowing on the planet. After their GeoMars exploration, students are introduced to a channel on the surface of Mars that could have been formed by flowing water or flowing lava. The question of this channel was formed is the focus of the remainder of the unit. The question of how this channel was formed is the focus of the remainder of this unit. Students begin to gather evidence for what formed the channel by observing aerial images of landforms on Earth that were formed by flowing water and some formed by flowing lava. Students learn that investigating geologic processes and landforms on Earth can help them understand what geologic process may have formed landforms on Mars. Students then move to Lesson 1.3, Investigating a Mystery Object on Mars. Students are introduced to the process of scientific argumentation. In the warm-up, students think about the everyday example of argumentation that prepares them for an introduction to the components of a scientific argument. Students then engage in argumentation about a real mystery that scientists faced a few weeks ago. A jelly donut-like object appeared in the path of the Opportunity rover on the surface of Mars in 2014. Students examine evidence and practice connecting the evidence to claims. They then apply these argumentation practices to the channel on Mars investigation as they return to the Chapter 1 question, what geologic process could have formed the channel on Mars? Chapter 2, Using Models as Evidence. The Chapter 2 question that students are focusing on answering, how can we gather more evidence about whether lava or water formed the channel on Mars? Students learn how models offer a way to gather evidence about processes that are difficult to directly observe. Through active reading and observing stream tables, they see how models are used to understand how geologic processes create landforms. They apply their understanding of models to help the investigation of the channel on Mars. In Lesson 2.2, Modeling a Geologic Process, students reflect on how models provide evidence to answer scientific questions. First, they return to the Investigating Landforms on Venus article to deepen their understanding of how Tara's model provided evidence of how Venus was formed. Then the class uses a flowing water model to gather evidence about what formed the channel on Mars. Students make observations of a stream table during the flowing water model demonstration and share these observations in a class discussion. This pairing of text-based and hands-on activity helps students learn how scientists use models to test ideas and gather evidence. In 2.3, Gathering Additional Evidence from Models, students continue to model to investigate the question, what geologic process could have formed the channel on Mars? First, students revisit the flowing water model to get evidence for Claim 1, flowing water formed from the channels on Mars. They generate ideas to test in the flowing water model and select one idea to test. They make observations and share these observations in a class discussion. Next, students are introduced to a flowing lava model via an engaging video. The flowing lava model allows students to gather evidence from Claim 2. Flowing lava formed the channel on Mars. Then students consider what they have learned about the model and how what they've learned helped answer the Chapter 2 question of how can we gather more evidence about whether lava or water formed the channel on Mars. Moving to Chapter 3, Analyzing New Evidence. The Chapter 3 question states, how can we decide which geologic process formed the channel on Mars? In the first lesson of Chapter 3, students are introduced to the Chapter 3 question, how can we decide which geological process formed the channel on Mars? They use the evidence gradient to review and evaluate the evidence they have gathered so far. Then they are introduced to new evidence, a triangle-shaped landform discovered at the base of the channel on Mars. Students use the evidence gradient to consider how convincing this piece of evidence is in relation to other pieces of evidence and consider which claim this piece of evidence supports. The purpose of this lesson is to introduce students to the process of evaluating evidence, an important component of scientific argumentation. In Lesson 3.2, Evaluating Claims about the Channel on Mars, students receive their final piece of evidence about the channel on Mars, an image of rock found in the channel area. Early in its visit to Mars, the Curious rover sent back images of a rock formation composed of sedimentary rock called conglomerate near the channel at the crater. Students evaluate one of these images with the assistance of rock samples and reference materials. They then work in pairs to connect this evidence to two claims about the channel on Mars using the evidence gradient. From this activity, students can determine which claim is better supported by the given evidence, and the class converges on the claim that flowing water formed the channel on Mars. The last lesson of Chapter 3, Reasoning about Evidence from Mars. Students review the evidence to construct final arguments about what formed the channel on Mars. In preparation for their written arguments, students discuss an example of a strong argument and a counterexample. While discussing, they focus on how each argument uses the process of reasoning to develop an argument. Students are then introduced to the reasoning tool, which they are using to develop their own constructed arguments. Teachers should model or help students with the reasoning about evidence and make sure that evidence is clearly connected to a claim. Partners can work together with the reasoning tool and then share their thinking with different partners. Students learn that reasoning is an important part for creating sound, logic, and convincing arguments in science. Students will then write an argument to answer the question, what geologic process could have formed the channel on Mars? Students are prompted to be convincing in their writing as they address a well-informed audience. The geologists at the Universal Space Agency. To help students get started, the teacher models writing a scientific argument, including demonstrating how to use sentence starters and a reasoning tool. Then students write their scientific arguments. Students' final argument also serve as a three-dimensional performance assessment with rubrics provided to indicate students' progress with unit-specific science concepts, cross-cutting concepts, and the science practice of constructing explanations. Engaging in argument from evidence and obtaining, evaluating, and communicating information. In particular, the assessment of the science practices can serve as a pre-assessment for which you can support students' growth in their writing across the year. At the end of this lesson, students consider further possibilities for exploring Mars. For the focus test, students will complete their answer to one of the claims. Answering the question, what geologic process could have formed the channel on Mars? Claim 1, flowing water formed the channel on Mars. Claim 2, flowing lava formed the channel on Mars. They should clearly state their claim, identify the best evidence, and provide reasoning which answers the following statements. Explain the geological process that most likely formed the channel. Explain how the channel on Mars is similar to the flowing water model. Explain how the triangle-shaped landform can give us information about how the channel was formed. Writing quality is 1 point, ensuring that they answer in complete sentences, use applicable unit vocabulary, and use appropriate sentence starters. Take some time now to actually take the performance task. The performance task exemplar reads, I think the channel was formed by flowing water. Looking at the images on the channel on Mars and channels on Earth formed by water, they look similar. They have similar curved branching shapes and both have triangle shapes at the bottom of them. When landforms on different rocky planets look similar, it is evidence that they may have been formed by the same geologic process. The strongest piece of evidence was the rock Curiosity found near the channel. It was made of different types of smaller rocks. On Earth, this type of rock found near channels formed by flowing water. On Earth, rocks found in or near channels formed by flowing lava are made of just one type of rock. So, I think it is more likely that the flowing water formed the channels on Mars. Moving to the unit assessment. In the unit assessment, students are going to create a model to determine whether in the unit assessment, students complete a written response with 4 parts. The end of unit assessment is designed to provide formative information about students' understanding of the cross-cutting concepts of systems and system models as it relates to content from this unit. It is set in a context related to the Geology on Mars unit, and students' performance indicates the support students may need or connections to systems and system models that may be built upon in future units. Thank you so much for listening. If you have any questions, please reach out. Next steps for teachers: 1, finish taking the unit assessment. 2, complete your unit internalization guide. 3, submit the unit Google form on kipste.org. Calendar out your unit, very, very important. Number 5, prepare for vocabulary and anchor charts. Number 6, organize your kit and materials. Number 7, start prepping and rehearsing your lessons. Thank you so much for your time. I hope you guys love science and teaching science as much as I do, and I look forward to working with you guys this year.